Thank you, CropLife Asia and Tata. Thanks to all other sponsors of the meeting. Thank you for the opportunity. Really a great honor and pleasure to join today's meeting. I'm Pamela Wang from China. I'm a field scientist and also Drone Application Coordinator of Field Science in Asia Pacific of Corteva. I'm also a member of CropLife Asia Drone Task Force. In Drone Task Force, I'm leading work stream of application technology. Here is today's content. Firstly, I want to give you a brief introduction of general situation of drone application in China, which is including key drivers, advantages and challenges, government policies, related standards generation, and market status. Then I will talking about the technology development trend and key aspects of best application practices. Finally, I will show you the field performance of products of member companies of CropLife Asia in the field. First, let's see the fast development and key drivers of drone application. First, let's see the rapid development. From the left chart, you can see that by 2022, the total market size of agro drones will reach to 11 billion RMB, which is about 740 million US dollars. From the right chart, you can also see that the fast development trend. You can also find that in this year, it is forecasted that the total number of drones will reach to 16,000 and total treated area will reach to 87 million hectares. The key drivers of this fast development are urbanization and aging population, labor shortage and high cost, land consolidation, strong government support like subsidies, strong needs of government to promote and improve sustainable development and green development of agriculture. And also the service cost of drone application dropping dramatically, which make it easily accepted by farmers. For the detail, you can see that the middle chart, China rural population quantity dropped sharply by 21% over the past 16 years. Let's have a further look. According to the National Bureau of Statistics, the proportion of the rural overage labor force aged 55 and above has exceeded 34%, and about 12 million people move from rural areas to cities every year. It is predicted that by 2030, the number of farmers involved in farming in China will drop to less than 3 million, and over half of them will be overage workers. So we see that aging population as well as urbanization, labor shortage, and high cost are the big challenges for China agriculture and government. Drone application is adopted by farmers quickly and supported by government strongly, since it can save time, labor, and water with high efficiency. It can better react to unfavorable weather condition, like seed moment to spray. It is more convenient to be used, especially on rice paddy, sloping field, mountainous areas, and high stock crops, etc. When we compare the drone application with other three kinds of ground sprayers, we found that in terms of work efficiency, it is the highest one, while in terms of labor quantity and water consumption, it is the lowest one. So just because of it is a labor time and water saving technology with high efficiency, it is mostly welcomed by farmer and government. Now let's take a look at its advantages and challenges. In terms of advantages, as I just said, that it is a labor time and water saving technology with high efficiency. It is more convenient to be used, on rice paddy, etc. It is safer to operators. It is proved good and comparable performance with backpack application in most cases. Related technology also optimized and matured quickly day by day. It also get strong market support and strong government support. And nowadays, the market chances are bigger and it expanded to more diversified application area and crops. And also service price is decreasing dramatically. Contrary to its advantages, there are some challenges which limited its development. Firstly, and very importantly, it is risk management, especially drift management, is still a big challenge. Secondly, sometimes the efficacy and crop safety is unstable, especially by techniques in using. And some service providers, their professional knowledge and skill are relatively low. And for some market, it is disordered with low and unreasonable price, with unstable service quality, and R&D work and policies, laws, and regulations making still fall behind the frequent upgrade of drones, and market is overheated, which caused some negative customer complaint. And the technical support and the training is uneven or insufficient. Now let's see the government policies and government needs. China government published a series preferential policies to strongly promote the development of drones. As you can see that this chart, it is government preferential policy of UAV until March of this year. Related departments released their policies, like the State Council, Ministry of Industrial and Information Technology, Ministry of Agriculture, Ministry of Finance, Civil Aviation Administration, etc. The main policies including vigorously promote the development of manufacturing, to support and promote technology innovation, research, and production, and also support logistics enterprises to use drones to provide aviation logistics services. And also secondary vocational schools added 9 UAV-related majors to their students. And new professions related to drones have been released, which is a country's recognition of talents in the UAV industry. Most provinces also issued a subsidy for purchasing drones. From the right chart, you can see the subsidy provided by provincial government in 2019. For example, in 2020, all major agricultural provinces in China, except several provinces, have included drones in their subsidy scope. And the subsidy amount for the drone over than 50 liters per tank ranged from 10,000 RMB to 25,000 RMB. And also in this year, UAV also finally captured to the National Subsidy Directory. This year, Ministry of Agriculture and Ministry of Finance released a note that issued the notice that printing and distributing the guiding options on the implementation of agriculture machinery purchase subsidies from 2021 to 2023. So the categorized of subsidized agriculture machinery and tools expanded to drones. You can also see other preferential policies issued by government. That is including one important needs or direction of central government, that is continuous promote sustainable and green development of agricultures. So we see that there are strong needs of government to promote and improve agriculture sustainability, sustainable and green development, and reduce use rate of pesticides by drone application is a common practice in some area of China now. On September of this year, the central government issued the 14th five-year plan for the green development of agriculture. It is suggested that ecological control, biological control, physical control, scientific use of pesticides, and other environmentally friendly measures should be taken to control pests. That is include promote new and efficient plant protection machinery. That is also included drones, which can improve the utilization rate of pesticides. Leading scientist Professor Yuan also found that the use of drones could increase the deposition of pesticides on target crops and reduce the loss of pesticides, thus achieve precise reduction in the pesticide application, which helps solve the pest control problem when the ground machinery can't be operated. From their study, and you can see that in the right chart, they also found that the benefit based on improving pesticide utilization is increased 4%, and the benefit is above 4% by improving working efficiency of drone application on rice. As a result, we know that China government is strongly promote the drone application. Now let's see the standards generation. The industrial is endeavored to improve the healthy development of drone application. International organizations like FAO, OECD, ISO, and CCPIA, ICAMA, such China organizations are all generating or plan to draft standards for drone application. For example, CCPIA have been generated a series of drone application standards in the past several years, and they will continue this work. And CCPIA is or will cooperate with FAO and OECD to generate some standards. China and Korea is leading some ISO standards generation work, and CropLife Asia will do related work too. OECD and FAO now are collecting drift data across global. Corteva also generated BAP or standards internally and externally. Internally, we generated 4 BAPs for 4 products, and externally, we jointly generated or participated some standards generation by cooperated with CCPIA. Finally, let's see the market status. Agriculture becoming the top 1 application field for the UAV. From the right chart, you can see that this is a statistics on the market share of main application fields of industrial UAV in China in 2020. Agriculture accounts for 42%. Besides, in terms of drone producers, DJI and XAG still dominate the agriculture market with about 90% market share. DJI's market share is 65, and it is 23 for XAGs. In terms of application crops, the top 4 key crops treated by drones are rice, wheat, corn, and cotton. The top 2 provinces are Xinjiang and Heilongjiang provinces. Fertilizer and seed spreading increased dramatically since 2020. Fruit application becoming research and market hotspot. From the right chart, you can see that the total treated areas on rice reached to 30 million hectares, and it is 17 million hectares on wheat. And Drone application also expanded to other crops like potato, sunflower, soybean, citrus, apple, vegetables, etc. Drones are mainly used for the application of pesticides and defoliants at the very beginning, but nowadays it is expanded to broader area like spreading fertilizer, seeds, spreading fodder, pollination, and transportation of agricultural goods. But drift and crop safety is still the big challenge of drone application. Problems like unscientific tank mixing using, unsuitable formulation, phytotoxicity on the field, and phytotoxicity due to the off-target movement or drift. So major MNCs are all conducting drift studies. After introduce the general situation of drone application in China, let's talking about its technology development trend and key aspect of best application practices. First, let's see the key technology progress and development trend. Nowadays, the drones becoming more intelligent and modularized with higher efficiency and user-friendly by combining some key technologies. For example, for DJI drones, work efficiency increased to 320 move per hour compared with 60 move per hour in the past. In order to satisfy different customer needs, there are two development directions for the load capacity. Smaller ones like T10, bigger ones like T40, or maybe V50 of XAJ. There are also continuous improvement of pump and nozzle, battery life, power consumption, charging system, obstacle avoidance system, and positioning system. For example, battery life improved to 15,000 circulations compared with 300 circulations in the past. And mapping, serving, and spring are progressively integrated. Drones are also developed to adaptable to sloping field and foot trace like T40 and EA30X. And spreading function improved continuously. We also see that precision application is extending or will extend to all areas of agriculture. Let's take DJI's T40 as an example. DJI launched the two types of drones, T40 and T20 Pro, in the middle of November this year. The major breakthrough features are, firstly, the load capacity further increased from 30 liters in the past to 40 liters. And the pump system also improved. Larger flow magnetic drive and propeller pump are used, which can separate motor, power or pump with pesticide mixture and avoid erosion and blocking. Centrifugal nozzle with dual automation function can realize an adjustable droplet size, which ranged from 50 micrometer to 300 micrometer. Coaxial twin propeller configuration with strong wind field can realize the droplet to penetrate to the thick canopy like fruit trees. Binocular vision and phased array digital radar can realize autonomous obstacles avoidance continuously. New camera equipped with Jumbo can collect real-time terrain information, and 3D images can reconstruct it locally and offline quickly. So the mapping, serving, and the spring are integrated together. Now let's move to the BEP's part. Before that, we must understand the influential factors of the performance of drone application. That is including environment-related factors like relative humidity, temperature, wind speed, wind direction, etc., and also air inversion, which is very important. pesticide and adjuvant-related factors like the active ingredient, the formulation, the physical compatibility of the pesticides, application rate, timing, numbers, interval, etc. And also the UAV-related factors like the models, the detail model types, the flying mode, the nozzle and pump type, the flying parameters, and also others like water volume. Now, I will expand my presentation by choosing some of the key factors. Please be noted that below information also captured to the CropLife Asia's drone application toolkit. Hope it is useful to you. The key aspects which I will touch on today are feasible formulation, proper tank mixing method, optimum droplet size, pump nozzle type, droplet size, environment parameters, flying parameters, and also spray quality evaluation. First, let's see the feasible formulation for drone application. Depending on research results of Professor Zhang Jun in China, we know that from this chart, the more plus means a better technical feasibility of this kind of formulation. We see that from this chart, UAV is most suitable on drone application, followed by AS, EW, SLX, and then ME, SC, OD, EC, WDG, WDT. This formulation showed moderate level of feasibility on drone application, and followed by a WP and SLX. They showed low level of feasibility on drone application. And for others like micro in capsule and DP and FU formulation, they are not suitable on drone application. So based on previous slide and other research results, here is our recommendation. Firstly, products with qualified formulations are recommended to be used. Feasible formulation for UAV are chosen for application. Compared with solid formulation, liquid formulation is more suitable or more feasible to be used on drones, and small-scale pretest is recommended. Prudence is needed for WP, SLX used on drones, since it is easy to block hydraulic nozzle. Prudence is also needed when EC used on drone application. ULV, SC, EW, CS, AS, SE, WDG can be used by drone application, but still has some defects. MEODDF, OFK might be the best formulation suitable on drone application. And for other three formulations, they are not suggested to be used on drones. Then we move to the proper tank mixing order and method. We should use proper method to dilute to tank mixing our pesticides. I know that most of you already grasp this. It is simple, but it is very, very important. We need to follow the correct tank mixing process. For detail, let's see this correct tank mixing order. Firstly, you can add solid fertilizer in the tank, and then other solid formulations of other pesticides with solid formulation. And then you can add other pesticides with liquid formulation. And finally, you can add surfactants, soluble fertilizer, and drift retardants. Small test of tank mixing capability should be conducted if there is need, and avoid tank mixing using with very concentrated spray mixtures. Now let's see the biological optimum droplet size and nozzle type. Depending on a research result by Dr. Wang Guobing, we know that there are different biological optimum droplet size for different pests. Compared with weeds control, pathogen, fungi, or or insect needs relatively fine droplets compared with weeds control. And you can also know whether the nozzles are fine or coarse nozzles depending on their colors. And the commonly used hydraulic nozzles are flat fan nozzle and hollow cone nozzles. For flat fan nozzles, lateral LU, lateral ST, TJET XR with VMD ranged from 100 to 200 micrometers are broadly used on row crops and plant growth regulators. For hollow cones like ConJet and lateral TR with VMD ranged from 100 to 150 micrometers, they are more suitable for the orchard application. While nozzles like RDK, which has a coarser droplet size and much narrower sprays walls, that is meant low work efficiency. So no application use of RDK and other related anti-drift nozzles. We know that there are two types of spray system, generally speaking, hydraulic nozzles and pump, rotating centrifugal nozzle, peristaltic pump, and magnetic drive impeller pump. And also the new pump equipped on the T40 by DJI this year. Each nozzle and pump have their advantages and disadvantages. So you can choose nozzles by understanding their attributes, their features. Due to the time limitation, I will not interpret detail. You can take reference from CropLife Asia drone application toolkit. So here is our basic recommendation on the nozzle, pump, and droplet size. For the nozzles, firstly, follow the recommendation of manufacturers. Then choose the right nozzle depending on the detailed pests, crop, environment, combining with flying mode and flying parameters. For the droplet size, it is recommended to use coarser or more larger droplet size when there's a potential drift risk. Use relative higher water volume and coarse droplet size for herbicide application compared with fungicide and insecticide application. Use higher water volume and fine droplet size for fruit application compared with row crops application. Use coarser droplet size for application of herbicide compared with application of fungicide and herbicide. In terms of the proper pressure of nozzles, use higher pressure for fungicide and insecticide application and use lower pressure to do the herbicide application, which can helpful to alleviate drift risk. Finally, let's see the detailed environment parameters and operational parameters of drones. First, let's see the environment parameters. We should not do the application when the wind speed is larger than 3 meters per second. And it is also not recommended to do the application when there is no wind. And the optimum temperature for spring is 24 to 30 centigrade. And it is also not to do the application when the temperature exceeds 35 centigrade. In terms of relative humidity, the relative humidity should be above than 50 to 60%. And if there is forecasted that rain will be fall within 4 to 6 hours, then no pesticide shall be applied. In terms of application timing of a day, to do the application before 10 o'clock in the morning or later than 3:30 in the afternoon, or apply pesticide during night, or to do the application when atmosphere is neutrally stable. Spraying is recommended between sunrise and morning when the airflow is relatively stable. Do not apply when there is dew. Do not apply when there is strong air inversion. Now, then let's see the flying parameters. All the recommendations based on our research, based on the recommendation of DGI and XAJ, and based on the application experiences in China. In terms of water volume, for row crops, it is 15 to 45 liters per hectare. And it is same for the vegetables. For fruit trees, it is ranged from 60 to 200 liters per hectares. And water volume should be adjusted appropriately according to the actual situation. And in general, the more water is used, the better control efficacy is. But that does not mean that you need to increase water volume as your will. It is not realistic. For the spray balls, the appropriate spray balls should be selected according to the performance of different models and should follow the recommendations of manufacturers' suggestions. And it is advisable that the deposition density of droplet size should be no less than 20 droplet size per square centimeters. For the operation altitude or flying height, it shall be 1.8 to 3 meters above the canopy. For the operation speed, it is less than or equal to 7 meters per second, or follow the recommendations of manufacturers. And you can also validate your parameters by using the following formula. This is a DGI recommended parameters on rice in China. And from this chart, you can see that they provided their recommendations on the application volume, the flying speed, flying height, and also fly line spacing, which is also spray balls to some extent. And they give their recommendations different according to different application scenario, according to different types of drones. Last but not least, where it possible, spray quality should be evaluated for any new products used by drone application or any products which never used by drones before. In general, the distribution uniformity of droplets or the coefficients of variation should be less than 45% or 65%. The droplet density should be at least larger than 15, 20, or 30 droplets per square centimeters. You can refer to the right chart, which comes from a China standard. At last, I will show you the drone application performance. In the past 5 to 6 years, technical feasibility was evaluated and confirmed on drone application by Corteva, Bayer, Syngenta, FMC for more than 93 products against rice diseases, rice insects, wheat weeds, wheat insects, and also potato diseases, corn pests, citrus diseases, and insects, etc. In most cases, we proved that all products showed very good technical feasibility by drone application on those crop species based on about 600 internal field efficacy trials, field crop safety studies, deposition drift studies, and also we found that no negative crop response was found, not only in these trials, as well as adjacent crops. Now let me give you some examples. For Corteva, we found good performance of Quinlex against wheat weeds control by drone application, which is comparable to backpack application. And also we found very good field performance of rice fungicide acantoway against the rice force mark control by drone application for Corteva, which is comparable with knapsack application. Similarly, Corteva found that their fungicide, Zovec Incantia, showed very good particulate blight control, which is comparable with knapsack application control under high disease pressure. We also found that very good field performance of Gemveva, a corn insecticide against corn fall armyworm control, which is comparable to backpack application 2 under a moderate pest infestation by Corteva. For Bayer, they found that better performance was found of drone application than knapsack application against rice diseases under moderate to high disease pressure. Bayer also found that their insecticide showed very good performance against rice pest control, which is comparable to knapsack application. Syngenta also found that one of their fungicide showed very good control on leaf blast control on rice. You can find that this is untreated check, and the other 3 photos are Philia. This fungicide showed very good control on leaf blast by drone application. So the final conclusion is that all tested products showed very good technical feasibility by drone application, and it is comparable with knapsack application under low, moderate, and high disease pressure. But under extreme pest infection or infestation situation, it is not recommended to use drones to control the pests. It is same for the knapsack application. Not a company can ensure satisfied control. Efficacy can be reached under severe pest infection or infestation scenario, and it is strongly recommended to strictly follow the direction for use of pesticide producers, drone manufacturers, and also local best application practices of drone application. So thank you for your attention. Thank you, Taita, and all other sponsors of this meeting. Thank you very much. That's all for my presentation.